Okay, guys, so this should be really short. This is H-32. So we've got three theorems right now. We've got the extreme value theorem, and for it, see page 164 in our Cycle H document. That's H-31, H31. And then we've got the intermediate value theorem and the mean value theorem. Those are on page 146, which is H28, if you want to follow the link in the calendar to it. So the directions state whether the given statement is the conclusion of the intermediate value theorem, the mean value theorem, or the extreme value theorem. And then part B, what information would we need in order to arrive at a given conclusion? Okay, so number one, x prime of t equals 5 for some t between -4 and 7. Guys, there's only one of these theorems that say that the derivative takes on a certain value, and that is the mean value theorem. Now, in order to apply the mean value theorem, there are two conditions that have to be true. Okay, x, the original function, not the derivative, x is continuous on the closed interval 4 to 7, that means it includes the endpoints, and x is differentiable on the open interval, -4 to 7, so not including the endpoints. So there can be sharp corners at the endpoints, but there can't be sharp corners anywhere else. It's got to be smooth and continuous. That's what differentiable means, smooth and continuous. So that's number one. Okay, number two. If we have the conclusion C of z equals -1 for some z between 3 and 9, that is the conclusion of the intermediate value theorem. Actually, oh shoot. For the mean value theorem, I wanted to say more. Darn it, I forgot. What information we need in order to arrive at a given conclusion? Okay, shoot. Okay, I have to redo the answer key, shoot. All right, the first thing for the mean value theorem, oh my gosh. First, we would have to show that x of 7 minus x of -4 over 7 minus -4 is 5. All right, first we'd have to show that. And then, well, maybe I did, the order doesn't necessarily have to go in this order, but we would have to show this somewhere. And then x is continuous on -4 to 7, and x is differentiable on -4 to 7. Okay, shoot, I have to redo the answer key. So yeah, that's what we need. I forgot. We need this information, and then we also need this information. Okay, now for the intermediate value theorem, so this is the conclusion of the intermediate value theorem. So we would need to show first that -1, wait, how do we do it? We go C of 3 equals blank. Yeah, we go C of 3 equals blank, C of 9 equals blank, and -1 is an intermediate value. You could just say between. You also could say -1 is between C of 3 and C of 9. All right, that's the first thing we need. And then on top of that, what has to be true about C? C is continuous on the closed interval, 3 to 9. Right? Now the third one. the conclusion is there is a value m that is between -8 and 0, but it could also be -8 or it could be 0. So this is a closed interval, for which k of m is greater than or equal to k of t for all the other t's on -8 to 0. Guys, this is the extreme value theorem. This is saying right here that k of m is an absolute max, that k of m, the output at m, is greater than or equal to all the other outputs for inputs on this interval. So that's the extreme value theorem. And guys, all you need for the extreme value theorem is that k is continuous on the closed interval. All right. So, yes. All right. Hopefully that was clear. And I got to go back and fix the answer key because I forgot to put, for MVT and IVT, we also need to say, we need some preliminary stuff before jumping into continuity for IVT. And we need, for MVT, this preliminary stuff before jumping into continuity and differentiability. Alrighty.